The professor wrote a wrong equation to trap the boy with cracked boots from the farm. But 10 minutes later, the entire academy went silent. Up north in Vermont, where maple leaves turn red like old embers and fall quietly onto stone steps, stood Grantham Preparatory Institute. The copper dome had long since turned green with time. The hallways were laid with polished oak, and the entrance lobby gleamed with cold, proud marble. That morning, a boy stepped through the iron gates, stitched with ivy and tradition. His shirt was wrinkled, and in his left hand he carried a cloth bag sewn from an old rice sack. His boots, heavy farm boots, were cracked at the heels, still caked with dried mud from Texas soil. His name was Thomas Hale. 16 years old, son of a late wheat farmer from Tulia, Texas, a dry, forgotten town with no movie theater, no shopping mall. There, life wasn't divided by semesters or holidays, but by the sowing and harvest seasons. Thomas had never seen snow. He had never eaten with a silver fork. But when he stepped onto Grantham's white marble floors, he did not stumble. He did not shrink. He simply glanced up at the copper dome as if reading the sky before a storm. His acceptance letter, now with one corner folded and torn, had called him a special applicant. But in truth, the school had taken him in because of one thing, a national math test, in which he solved a complex 3D geometry problem using nothing but a sketch of how his family stacked hay in their barn. Thomas wasn't the fastest student, but the way he approached the problem made the judges pause, reread, and then fall silent. Much like today, as he walked through the main hall, not one person stared too long, but the sound of polished shoes on marble seemed to slow when he passed. At Grantham, every student wore a tailored uniform, crisp tie, and polished leather shoes. Thomas's shirt looked like something worn to shovel manure, but he didn't bow his head. Thomas kept walking, eyes steady, quiet brown eyes, the color of soil after rain. Not proud, just certain. A quiet certainty brought from dry fields, and from something his mother once told him. You don't have to stand out, Thomas. You just have to look closer than the others. He remembered that sentence more clearly than any formula. Room 3A, Lancaster Hall. Thomas opened the door to his dorm and met his roommate, Wesley Hartwell III. Wesley didn't greet him. His eyes scanned the cloth bag, the cracked boots, and the corner-scorched notebook Thomas carried. He didn't speak, but he didn't need to. The distance between them had already been drawn, like a line scratched into dry earth. Wesley was the grandson of a Grantham benefactor. He brought a leather suitcase, a handmade chess set, and 2 bottles of French cologne. Thomas brought a worn blanket, a broken pocket watch, and a notebook his father left behind. That night, Thomas didn't sleep early. He opened the notebook and flipped to page 30, where he had drawn the underground water map beneath their farm. It was his first lesson in pressure, flow rate, and applied mathematics, not from textbooks, but from watching his mother water crops by hand during the drought of 2021. The next morning, Thomas entered advanced mathematics. The professor, white-haired, sharp-eyed, stepped in and wrote a strange equation on the board. It was a differential form, half-finished, flawed. Thomas did not react. He copied it quietly, like a farmer watching the clouds, never rushing to predict rain at the first sign. He waited. He studied. He let the problem finish speaking. At Grantham, speed was everything, but Thomas knew better. Trees don't grow in a night, and the soil will tell the truth if you're patient enough to listen. Lunchtime. The grand dining hall with chandeliers and crystal glassware. Thomas unwrapped a sandwich packed in old newspaper. As he unfolded it, the scent of dry ham and mustard drifted through the air. A few boys laughed. One of them said aloud, "Didn't know cowboys could count." No one objected. No one defended. Thomas just chewed slowly, holding his notebook under the table. Some eyes looked down with pity, more with disdain. But Thomas didn't flinch. He remembered his mother's voice. They don't have to believe in you. You just have to believe in what you're doing. That night, after Wesley went out, Thomas sat beneath the dorm's yellow lamp and rewrote the intermediate value theorem. It says, if a function is continuous on the interval from a to b, and fa is negative and fb is positive, then there must exist a value c between a and b, where fc equals 0. But Thomas didn't just copy it. He told it again, in his own words, like he was telling a story to a child in a hay barn. Then he wrote something beneath it. When two things pull in opposite directions, there is always a point in between, where the truth stands still. Later, when Thomas would be known as the Cascade Boy, people would ask, weren't you afraid? Stepping into a school full of legacies and trust funds. Thomas would smile. Of course I was, he'd say. But I think the earth was scared too, the first time it cracked open for a seed to grow. Still, it opened. And that's what Thomas Hale brought to Grantham. Not pedigree, not money, not even confidence. Just a belief that every problem has a balance point. You don't need to shout. You need to listen. The next morning, as Thomas headed to physics class, a girl tripped on the slick marble floor. Without hesitation, he caught her by the elbow. His cracked boots skidded a bit, leaving muddy prints on the white floor. Wesley walked by and muttered, "Disgusting." Thomas looked down at the mud he had tracked. For a moment, he stood still. Then he smiled gently. "Not all dirt is filth," he said softly. "Sometimes it's where things start to grow." At Grantham, there were unspoken rules. No one wrote them down. No teacher stood up to explain them. But they were there, like the cold that lingered in polished corridors, like trained eyes that measured a person's worth in the time it took to notice the brand of their shoes. Thomas Hale's old shirt, neatly ironed by his mother's hands, never stood a chance against those rules. It was called farmhouse pajamas on his second morning. His boots, cracked at the heels and soft from years in Texas soil, were quietly referred to as noise hazards. And Thomas? He became invisible. No one spoke to him between classes. No one invited him into the study circles forming in the library corners. In the grand dining hall with ceilings so high that laughter echoed like a theater hall, Thomas always chose the same table by the window. Quiet. Quick. Unnoticed. By the second week, the air began to tighten. That lunch, the menu was smoked meat, warm barley bread with butter, corn chowder, and chilled fruit. Students sat in neat, familiar cliques. Conversations about Harvard, Princeton, and Yale floated from table to table like the soft hum of crickets on a warm night. Thomas carried his sandwich, 2 slices of bread, a thin piece of ham, wrapped in reused paper, and searched for a seat. No one looked up. But when he placed his paper bag on the table, Wesley, his roommate, was already sitting there, along with a few others. A boy named Graham, son of a prominent orthopedic surgeon, squinted at him. "You lost, cowboy?" he asked. "This table's for freshmen with SATs over 1580. Thomas nodded politely. "I just needed a seat." Graham grinned. "Maybe the stables are more your speed. No invitation needed there." The table burst out laughing. Sarah Chun, the sharp-eyed girl from calculus, glanced over. Her eyes lingered on the corner-scorched notebook Thomas carried. She didn't smile, but she didn't laugh either. Graham leaned in again. Bet in Texas they only count cows. Probably still using fingers for addition. Thomas met his eyes. Calm. Still. He opened his notebook and began writing. Slowly, carefully, like someone watering a dry tree 1 cup at a time. Wesley rested his chin in his hand and said quietly, "Maybe he's just here to mop the floors, not study on them." More laughter. Forks tapped against plates like a cruel rhythm section. Thomas stood, not fast, not offended. He folded his notebook like a man tying shut a seed sack before the storm arrives. Then he spoke, softly, the way wind talks to wheat. "In Tulia, we don't count cows. We count water underground to see if there's enough to save the crops. We read fertilizer to measure soil health. We read shadows to measure evaporation." He paused. "And we know, if you laugh too soon, you might miss the moment the seed splits open." Silence. Utter silence. Graham looked away. No one said a word. Just the quiet clink of a spoon falling against porcelain. Thomas turned and walked to his usual table near the window. This time, the sound of his boots on the tile rang out, louder, sharper. That night, rain came to Grantham. Thomas didn't sleep. He sat by his desk, notebook open under a small reading lamp. Outside, the wind carried the scent of wet leaves and cold earth. He flipped to a clean page and redrew the intermediate value theorem, but instead of equations, he drew land. Two opposing points, a dry, cracked field between them, and in the center, a single drop of water. Then he wrote, "If one side is contempt and the other side is effort, somewhere between them the truth must live, and no one can bury it." The next morning, advanced mathematics began with a review exercise. Professor Whitmore walked in, expression unreadable, and wrote a complex logic sequence on the board, a proof by contradiction. The room went silent. Pencils began scratching furiously. Thomas looked up. His eyes moved slowly down the sequence until he saw it. A contradiction. Subtle. Clever. The kind that would escape even the top of the class. He raised his hand. Whitmore looked up, a little surprised. "Yes?" "There's a contradiction in line 3, Thomas said quietly. "Explain." "If we accept the hypothesis as true, then in step 3, the auxiliary variable creates a paradox. The condition for exclusion collapses. The proposition ends up disproving itself." The classroom froze. Whitmore looked at the board for a long second. Then, without a word, he erased line 3 and rewrote it. No lecture, no praise, just chalk and silence. But it wasn't just any silence. It was respectful silence, the kind that no longer pretended Thomas didn't exist. That evening, Thomas returned to his window seat. The wind whispered like it did back home. He opened his notebook and reread the line he'd written. "When two opposing forces meet, there's always a balance point where the truth stands still." And for the first time since arriving at Grantham, Thomas smiled. Not because he'd been noticed, but because that balance point, the one he always believed in, wasn't in a theorem today. It was right there, within him. In life, there are moments that arrive without warning, moments that make every wound, every silence, every quiet act of perseverance suddenly make sense. One such moment arrived for Thomas Hale on a still Wednesday morning, beneath the soft, amber sunlight filtering through the tall windows of the math lecture hall. It began with a single line of chalk. The course was theoretical mathematics, part of an elite seminar led by Professor Edgar Whitmore, a revered, rigid figure at Grantham. He was famous for impossible questions and an intolerance for mediocrity. His hair was as white as ash, and his eyes were as sharp as cold steel. That morning, he walked into class without a word. No greeting, no syllabus, no context. He stepped up to the board, lifted a stick of chalk, and began to write. No explanations, no hints, just a single sprawling equation, clean and elegant, yet dizzyingly complex. It stretched across the board like a landscape of symbols and logic. Students bowed their heads and began scribbling furiously. A few tapped their tablets. Some flipped pages in textbooks already flustered. But Thomas didn't write. He sat still. Not because he already had the answer, but because he wanted to understand why the problem had been written the way it was. Back in Tulia, years ago, Thomas once watched his mother lose sleep for 3 nights over a row of cabbage that wouldn't sprout. She believed the soil had gone sour. But Thomas, only 13 at the time, got out his notebook, mapped the tilt of the ground, and discovered that the irrigation water had veered just 1 degree off course. Just 1. The roots hadn't failed. The flow had shifted. Just like this equation. Something about it was off. 1 line right near the center of the board. To everyone else, it looked like a transitional expression in a proof. To Thomas, it tilted the entire system out of balance. A subtle contradiction. A misplaced constraint. Something that rendered the whole structure unstable. He raised his hand. Chairs creaked, heads turned. Whitmore narrowed his eyes. Yes? Thomas stood. His voice was soft but steady. Sir, I believe this system doesn't hold under the assumption in line 6. Whitmore blinked once. Explain. If the constraint f(x0) remains as written and matrix A becomes degenerate, the system collapses. It no longer models a physically consistent state. A long pause followed. Whitmore didn't move. One hand still held the chalk. The other gripped the edge of the board. And then he smiled. Not kindly, not mockingly, but like someone who had waited a long time for something to happen. Have you studied Jacobi reduction? No, Thomas replied. But I've used something similar to correct flow errors in our irrigation system. When water pressure drops unevenly, the system oscillates in reverse. I stabilized it using matrix simplification. Silence. Not one student spoke. Not because they didn't believe Thomas, but because they now did. Whitmore slowly set the chalk down, turned back to the board, and erased line 6. Without another word, he returned to his desk. The lecture ended quietly. No fanfare, no comment. But Whitmore didn't leave. He remained at his desk, waiting until the room had emptied, except for one student. Then he walked over to the back row, where Thomas was gathering his notebook. Do you know what that equation was? Whitmore asked. Thomas shook his head. That was a section from my doctoral thesis, submitted to MIT in 1982. No one, not even my committee, noticed that flaw. Neither did I. Not until 2 months ago. Thomas was silent. Whitmore sat across from him. His voice softened, as if speaking from a room deeper inside himself. I copied it deliberately, mistake and all. I wanted to see if anyone would catch it. Not someone clever, someone clear, someone still enough to see it. Thomas met his eyes. I didn't know it was a test. Exactly, Whitmore said. Which is probably why you passed it. He picked up the weathered notebook lying half open on the desk. May I borrow this? Thomas hesitated, then nodded. He had no idea that this small gesture would change everything. That evening, Thomas called home. The phone line crackled faintly across 2 states and a lifetime. You doing all right? His mother asked, voice low and calm as ever. I saw something wrong in class today, Thomas said. You fix it? I just asked about it. A pause. Then her voice came through the line like an old song. Most folks don't listen to a problem long enough to hear where it stumbles. But you don't rush. You wait. Thomas smiled. Outside his window, the maple trees were burning red in the fading light. Leaves drifted in spirals toward the earth. He stared out, then whispered to no one in particular, "Some flaws aren't meant to be fixed. They're meant to reveal who's still listening." At Grantham, originality was spoken of like an heirloom, admired, protected, but rarely touched. Students competed to master what had already been discovered. Few dared to invent. Even fewer were taken seriously when they did. So when Thomas Hale, the boy from Tulia with cracked boots and a sunburnt notebook, introduced a new mathematical method that wasn't in any textbook, most of the room didn't know whether to laugh or to listen. Sarah Chun chose to listen. It began with a problem no one could solve. A multivariable optimization equation, non-linear, tangled with conditional branches. It sprawled across the board in symbols that looked more like river maps than mathematics. Whitmore introduced it with one line. "This equation resists all conventional methods. Assume that's on purpose." Then he stepped back and folded his arms. Some students tried gradient descent. Others applied Newton's method, Lagrangian multipliers, even simulated annealing. All failed or collapsed midway. Thomas sat quietly. He didn't raise his hand. He asked a question. What if the solution isn't a single answer but a sequence of smaller answers that reduce pressure gradually? Whitmore raised an eyebrow. Thomas stood. He walked to the board, and in that calm, humble voice that always sounded like it came from a place far beyond the walls of any academy, he began, "In Tulia," he said, "we don't try to force the entire irrigation system to stabilize at once. We build cascades, layers of pressure drop. Each channel receives water only when the one above it is full. That way the flow doesn't burst. It continues." He picked up a piece of chalk. In this equation, each condition contradicts the next when solved simultaneously. But if we treat them as tiers, one feeding into the next, we can reduce total instability. The room was silent. Thomas redrew the problem, not as a block of math, but as a waterfall. At each level, he applied localized solutions, then connected them with boundary logic. It wasn't perfect, but it worked. He stepped back. "I call it the cascade method," he said simply. Sarah, who had said nothing for 2 weeks, leaned forward in her seat. She wasn't watching the board. She was watching him. She had seen fast thinkers before, students who could race through calculus without blinking. But this was different. This wasn't speed. This was depth. Like watching someone dig into frozen ground, layer by layer, not with force, but with patience. After class, Whitmore approached Thomas in the hallway. He didn't speak right away. He simply extended a hand. "May I borrow your notebook again?" Thomas nodded. Whitmore took it under his arm. Then, with a pause, he added quietly, "You didn't learn this method here." Thomas shook his head. "No, sir. I built it one summer when our east field dried out. We had to redirect the irrigation through 5 separate trenches. Each one had to release just enough to let the next one breathe." Whitmore looked at the boy, then at the notebook in his hand. "You built it, from dirt and water." Thomas smiled faintly. "That's where all math comes from, isn't it?" That evening, Whitmore sat alone in his office. The only light came from a brass lamp and the golden hour leaking through a narrow window. He flipped through Thomas's notebook. Inside were no definitions, no citations, no formal theorems. But there were ideas, clear, brutal, beautiful logic, woven with diagrams of trenches, rain maps, crop yields, and formulas connecting flow pressure to decision thresholds. There were no footnotes, only fingerprints. At the bottom of one page, Whitmore found this line, scribbled in pencil. "Don't push the whole problem. Let it step down, like water." He sat back. And for the first time in years, Professor Edgar Whitmore didn't feel old. He felt like a student again. The next day, Sarah Chun approached Thomas at breakfast. She didn't smile, but she sat beside him. For a moment, neither spoke. Then she reached into her bag and pulled out a sheet of paper. "This is a problem from my mother's doctoral work," she said. From before she had to give it up. Thomas looked it over. It was a non-linear system with chaotic feedback, untamed, unsolved. "I don't want you to solve it," Sarah added quickly. "I just thought you might see something I missed." Thomas nodded. He didn't open his notebook. He didn't write. He just stared at the problem, then whispered, "If it's chaotic, maybe the flow's trying to tell you where it wants to stop." Sarah blinked. Then, for the first time since arriving at Grantham, she smiled. Not because of the answer, because someone finally saw the question. For weeks, Professor Whitmore said nothing. He took Thomas's notebook. He read it. He kept it. He returned it days later without a word. No comment, no question, no praise. Just laid it gently on Thomas's desk like an item borrowed from a museum. But then came Friday, and with it, a truth that had waited too long to be spoken aloud. Class began like any other. Students filed in, murmuring about problem sets and test prep. Sarah Chun sat 2 rows closer to Thomas than usual. Wesley, the roommate who once mocked the boots, now glanced over often, but said nothing. Then, Whitmore entered. He didn't head for the blackboard. Instead, he placed a stack of papers on the podium and turned to face the class. "I'd like to begin," he said, "with a confession." The room fell silent. The confession of a professor was not a thing one heard at Grantham. He looked around the room. Not at the brightest students, not at the legacy kids. He looked at Thomas. "The equation I wrote last week, the one with the contradiction, was wrong. Deliberately wrong." He let the words settle. "I wrote it that way, to trap one of you." A few students shifted uncomfortably. "I wanted to prove something," he continued. "To myself. To the academy. To the system." He paused, voice lower now. "I wanted to prove that a boy with a burned-up notebook and broken boots didn't belong in this room." Thomas didn't flinch, but his fingers, resting on the table, curled just slightly inward. "I had my doubts," Whitmore said. "I thought there was no way someone from a dried-up town in the Texas Panhandle could spot what MIT professors missed in a doctoral defense." His voice cracked, not out of shame, but weariness. And then he did. No one in the room moved. It wasn't the kind of silence born from awkwardness. It was reverence. The silence that enters when something true is finally spoken. Whitmore stepped away from the podium and faced Thomas. "I tried to trap you, Thomas. But you didn't just avoid the trap. You filled it in, replanted the ground, and somehow you made something better than what was there." He bowed his head in front of the whole class. "I'm sorry." For a full breath, Thomas said nothing. Then, in a voice calm as evening wind, he answered, "Dirt doesn't lie, sir. People do. But the earth, it only grows what's inside it." Whitmore looked up. His eyes were glassed, not with pride, but with something deeper. Gratitude. After class, a small crowd gathered around Thomas. Some asked questions, some said nothing, just nodded. But what they were truly saying, each in their own way, was, "We see you now." And yet, Thomas didn't raise his voice, didn't puff his chest. He simply opened his notebook to a clean page and began working quietly on a new problem, until someone tapped his shoulder. A staff assistant from the dean's office. "You've been nominated," she said, "for the National Mathematics Olympiad team." Thomas blinked. "I didn't apply." "No," she smiled. "You were submitted by Professor Whitmore himself." That night, Thomas sat alone at the edge of the quad. Above him, the Vermont sky was a quiet cathedral of stars. The trees rustled like voices too old for language. He took out a pencil, turned to the back of his notebook, and began to draw. Not numbers, not graphs, just lines. Gentle, cascading lines. Like water stepping down a hill. Like truth, settling slowly into soil. Back home in Tulia, his mother sat by the kitchen window. The phone hadn't rung yet, but she didn't worry. She looked out at the east field, dry, cracked in some spots, soft in others, and she whispered, as if to herself, "He's not just learning their numbers. He's teaching them how to listen." The auditorium at Grantham had hosted Nobel laureates, visiting scholars from Oxford, and 5 former U.S. presidents. But on this particular Thursday morning, it belonged to a boy who once mapped irrigation by candlelight. The lecture was never meant to be public. Originally, it was scheduled as a closed session, a technical workshop on applied systems theory for graduate students and faculty. But word spread, not through posters, not through emails. It spread the way a breeze does before rain, quietly, persistently. People said things like, "He built the method himself. He solved a chaos system using trench logic. He's not from Harvard or MIT, he's from a barn in Texas." And so did. The room filled. Professors sat in the back. Students lined the walls. Even the dean slipped in, unnoticed. At exactly 9 o'clock, Thomas Hale stepped to the front of the room. He wore the same shirt he'd brought from Tulia. It was cleaner now, still frayed at the cuffs. His boots had been polished, but the cracks remained. He didn't clear his throat. He didn't thank anyone. He simply began. "In the summer of 2021, he said, our east field in Tulia stopped growing. We hadn't seen rain in 91 days. His voice was soft, measured. We had 1 water source, 5 trenches. My mother said if we couldn't reach the roots before week's end, the entire crop would die." He paused. "I didn't know what to do. So, I tried to listen." He stepped to the board and began to draw, not symbols, but channels, sloping lines, and pressure diagrams. "I noticed that when we released water all at once, the system collapsed. It burst through the dry soil, created chaos, and left nothing behind." He drew a series of curved steps, each one shallower than the one before. "But when we created levels, steps, each trench absorbed just what it needed. No more, no less. The pressure softened. The flow continued." He turned to face the room. "I didn't know it then, but what we were doing had a mathematical name." He pointed to the board and said, "Pressure changes over distance. That's all it was. 1 small release at a time. In irrigation, it saved our field." He paused again. "In systems theory, it became a method." He redrew a problem from the previous week, the one no one could solve. And step by step, he broke it down. Not with force, with rhythm, with softness. Like pouring water down a dry hill and knowing when to stop. When he finished, he stepped away from the board. The room was still. Not a single cough, not a single pen tap. Professor Whitmore, seated in the back, didn't move, but his eyes were shining, not with pride, but with something deeper, understanding. After the talk, students gathered at the front. Some carried notebooks. Others just stood there, unsure of what to say. One doctoral student finally asked, "How did you come up with this?" "The cascade method?" Thomas looked at his hands. "I didn't come up with it," he said. "I just watched the field until it made sense." That night, Whitmore returned to his office. He took out a large envelope. Inside was a manuscript. The cover read, "The Cascade Principle, a layered flow framework for system stability." Author, Thomas Hale. At the top, Whitmore wrote by hand, "From Trench to Theorem." He signed it, then quietly sent it to the Journal of Mathematical Modeling, without asking, because some ideas don't wait for permission. Back in his dorm room, Thomas received an email. Subject, MIT Inquiry. Method Presentation. He didn't open it. Not yet. Instead, he sat at his desk and opened a small jar filled with dry red earth. He let the scent rise, then placed it next to his notebook, as if to say, "This is where it began, and no matter where it goes, it will always return to this." It was called the Camp of 30. 30 students. 30 of the sharpest mathematical minds from across the United States. Each had scored in the top 1% of national exams. Most came from elite schools with private coaches, summer programs, and family trees filled with ivy-covered walls. And then there was Thomas Hale, from Tulia. He arrived with a single duffel bag, 2 button-down shirts, and his notebook, its corners still singed from a fire that happened when he was 11, trying to read by oil lamp after a storm knocked out the power. The camp was held at a university in the Northeast, its architecture part Gothic, part modern, like old wisdom wired for speed. The schedule was brutal, 8 hours a day of pure problem-solving. No lectures, just one challenge after another. Students worked in pairs, groups, and alone, against time, against complexity, against each other. Most approached problems like races, but Thomas approached them like rivers. He never rushed. He listened. On the 4th day, the instructors posted a problem without context. No category, no credit, no prize, just a single sheet of paper on the board outside the dining hall. Extra challenge, it read. Most students glanced and kept walking. Some took photos. A few laughed. But Thomas stood in front of it for almost 15 minutes. Then he copied it by hand into his notebook. That night, the lights in the dormitory burned long. Students argued over logic trees and probability chains. Thomas sat at the end of the hallway, alone, cross-legged on the floor with a piece of bread in one hand and his pencil in the other. By morning, he had written not 1 but 3 different solution paths. Each one built from a different way of seeing. One was analytical. One was geometric. One was what he later called narrative logic, where the problem unfolded like a story, not a proof. When the instructors collected the attempts, they found mostly fragments. One solution came close. Only one had all 3 correct paths. It was signed, Thomas Hale, Tulia. The next morning, a tall boy named Timothy approached him during breakfast. Timothy was the #1 seed going into the camp, a legend among the math circuit. Olympiad gold, published papers, family of engineers. He didn't sit. He just stood, holding a paper plate and a quiet storm in his chest. "I worked on that problem for 7 hours," he said. Thomas looked up. Timothy's voice was calm, but not casual. "I only saw one solution," he continued. "It never even occurred to me that there could be more." Thomas folded his notebook. "I didn't try to be clever," he said. "I just looked at it the way I look at the land back home. Sometimes one field grows wheat, another grows corn. Same sun, same soil, different depth." Timothy blinked. Then he sat down. Not because he had to, because he wanted to learn. The final week of the camp, each student was given a private session with a senior instructor. Thomas was assigned to Dr. Ames, a former Olympiad winner, now silver-haired and slightly hunched, like someone who had bent too long over hard questions. They sat in a small study lined with chalkboards. Dr. Ames offered him tea, then handed him a packet. Inside were problems, some easy, some hard, and one so complex that Dr. B. Ames himself had once called it unsolved but approachable. Thomas turned the pages slowly, then looked up. "This last one," he said. "It looks like something Professor Whitmore would write." Ames raised an eyebrow. Thomas added, "There's a false symmetry in the third section. That's the trick, isn't it?" Ames didn't answer. He just leaned back and smiled. Later that evening, as instructors reviewed their final notes, Dr. Ames wrote one sentence beside Thomas's name. "He doesn't solve problems. He listens until they reveal themselves." When Thomas returned to his dorm that night, he found a note under his pillow. It wasn't signed. It read, "You've changed how I think. Not just about math. About everything." He didn't know who left it. He didn't need to, because by now he understood something deeper. Real brilliance doesn't shine. It reflects. It doesn't arrive with noise. It arrives like rain. Quiet, steady, and unmistakably real. The National Math Olympiad was held in a government building in Washington, D.C. Not ornate, not grand, just clean walls, quiet halls, and heavy silence. They didn't need decorations. They had numbers. 42 points, 7 problems. Each problem worth 6 points. Most students would dream of scoring above 35. No one had ever scored a perfect 42 in the last 39 years. Not even Whitmore, who once came close. That morning, Thomas Hale walked into the room wearing the same cracked boots and the same calm expression he wore the day he first stepped onto Grantham's marble floors. He had no coach, no cheering section, only a watch that didn't tick and a pencil he had carved himself. The first 6 problems came and went like clouds. He didn't rush. He didn't pause. He worked through them like a farmer walking rows, each one examined, tended, then left behind. By lunch, the scores were already separating. Some students looked pale. One had tears in his eyes. But Thomas? He was outside, sitting on the steps, sharing a sandwich with a pigeon. Then came problem 7. No hints, just a single sentence. Let n be an even integer greater than 4. Express n as the sum of 2 primes. The room inhaled. It was a variation of the Goldbach conjecture, a famous problem in number theory, unproven for over 250 years. It had never been used in a high school competition. Until now. Thomas looked at the sentence, then closed his eyes. He didn't scribble. He didn't write. He just listened. Back home, when the rain refused to come, his mother used to stand outside and say, "The ground is speaking. It just isn't loud." Thomas had learned to hear quiet things, and this problem, this ancient unsolved riddle, wasn't asking to be broken. It was asking to be heard. He picked up his pencil and began, not with brute force, but with logic pulled from the soil of Tulia. He modeled the distribution of even integers the way he once modeled irrigation pressure, slowly stepping down, tier by tier, checking every release. Instead of looking at primes as weapons, he treated them as seeds, searching for where they naturally grew when planted in pairs. It took him 70 minutes. Then, with the gentleness of someone finishing a prayer, he set his pencil down, and didn't touch it again. 2 weeks later, the results arrived. Official envelope, Grantham crest, black ink on white paper. Headmaster Reynolds opened it in front of the math department. He adjusted his glasses, cleared his throat, and whispered, "Perfect score." Whitmore leaned back in his chair, eyes closed, hands folded. It had finally happened. 42 out of 42. The letter was forwarded to Thomas's dorm room. Wesley handed it to him at the door, said nothing, just nodded. Inside was a short note, handwritten at the bottom by a senior judge. You didn't defeat the problem, you understood it. That is rarer than genius. That evening, Thomas walked across campus. The wind was soft, the moon was low. He stopped under a tree and pulled out the same notebook, the one burned at the corner, filled with diagrams and smudges and quiet truths. He opened to the back and wrote only one line. Some problems don't need solving. They need listening. Then he closed the notebook and looked up at the stars. Not as symbols, not as coordinates, just as they were. Quiet, steady, and somehow familiar. The auditorium at the National Math Honors Ceremony was built to impress. Velvet curtains, polished oak, marble busts of mathematicians who had once rewritten the laws of numbers, and in doing so, written themselves into history. Above the stage hung a banner, celebrating the minds that shape tomorrow. Every seat was full. Teachers in suits, parents with cameras, students dressed like future senators. Everyone knew who would win. Everyone expected the name, Timothy Monroe, 3-time national champion, Olympiad veteran, son of 2 MIT professors. His seat, front row, was marked with gold ribbon. 2 chairs behind him, unnoticed by most, sat Thomas Hale, in a jacket that didn't quite fit, with boots that still bore the scars of red Texas dust, and a folded piece of paper in his pocket, a note from his mother that simply read, "Be still. The world turns fast enough on its own." A hush fell over the crowd as the final award was announced. The presenter, a silver-haired scholar with a voice like a cathedral bell, stepped to the podium. "The winner," he began, "of this year's National Mathematics Medal is not from a legacy institution. He is not from a lineage of professors. In fact, he is not listed in a single alumni family tree." He paused. A few heads turned. The presenter looked down at the card in his hand. "Thomas Hale," he said, "from Tulia, Texas." Silence. Not applause. Silence. As if no one quite understood what they had heard. Then Whitmore stood, slowly, without a word. He placed one hand over his chest and bowed. The silence broke. Not with noise, with awe. Then one by one, others stood too. Professors, students, even Timothy Monroe. Not because they had to, because they knew. They had seen it. A boy who hadn't climbed the ladder, a boy who had built it himself. Thomas walked to the stage without looking at the crowd. His steps were even, his breath calm. At the podium, he unfolded the note in his pocket and began to speak. "I don't come from a place where math is taught like it is here," he said. "I come from a town where numbers mean bushels, gallons, rainfall." He paused. "Back home, a problem isn't something you solve. It's something you survive. And you don't rush through it. You sit with it. You wait." The audience leaned in. "My mother once told me," Thomas continued, "you don't have to be louder than the world, just truer." He looked up. "I am not a genius. I'm just someone who listened long enough to hear the answer whisper." Then he stepped back, and the room rose to its feet. Not in celebration, in respect. That night, as the guests dined beneath chandeliers, Thomas sat at the edge of the hall, sipping iced tea and watching the lights shimmer on the floor. Whitmore approached, held out a small envelope. Inside was a formal letter. "Grantham Institute is establishing a new scholarship," Whitmore said, "for rural students, for children of farmers, for thinkers whose hands know soil better than silverware. Thomas looked down at the letter, at the bottom, in neat print. The Hale Initiative. He looked up. "I don't know if I deserve that," he said. "You don't," Whitmore replied. "None of us deserve the land we're given." He paused. "But we take care of it anyway." Later that night, back in his dorm room, Thomas unpacked his jacket. Carefully, he pinned the medal inside a folded towel, then reached for his notebook. He opened to the last page and wrote, "You don't have to belong to their family, just be willing to feed the tree." Then he blew out the lamp and let the quiet return. Before he stepped onto MIT's campus, before he shook hands with deans and walked through halls built like cathedrals to science, Thomas Hale went home, back to Tulia, back to the wind, back to the barn. The town hadn't changed much. The gas station still had one pump. The diner still served coffee in chipped mugs. The land was still dry. But it was waiting, like a field at rest, not finished, just between seasons. Thomas arrived with a backpack, a small suitcase, and 2 boxes of used chalk. Inside the old hay barn on their property, he swept the dust with a broom that used to be a rake. He propped a blackboard against the far wall, cracked, chipped, but solid. He wrote a single sentence on it. "If you can count fence posts, you can do geometry." Then he opened the doors and waited. At first it was just 1 kid, then 2. By the end of the week, 6 children came from surrounding farms. Shoes too big, shirts handed down, some too shy to speak. He taught them not in formulas but in movements. He taught fractions by slicing apple pies from the diner. He taught volume by filling milk jugs with soil. He taught angles by watching shadows move across the barn floor as the day passed. No one took tests. They told stories. They asked questions. And Thomas listened, the way his mother had taught him, with stillness, with patience, like a man watering seed that might not bloom for years. One evening, as the summer neared its end, a small girl asked him, "Are you a teacher now?" Thomas paused. He looked at her chalk-covered hands, her smudged face, then at the dusty blackboard, where someone had drawn a crooked triangle and labeled the angles wrong, but proudly. "No," he said. "I'm a farmer. I'm just planting thoughts this time." The day MIT called again, asking if he'd arrive early for orientation, Thomas answered gently, "I'll come, but I need to finish my summer crop first." He didn't mean corn, he meant kids. On his last day in Tulia, he packed slowly. He placed his old notebook in a wooden box, tied it with string. On the last page, he had written one final line. "Not all storms come to destroy, some arrive to open the land." Before leaving, he walked out to the barn. The sun was low. Wind moved through the slats like breath. He left the doors open. The blackboard stood ready. On it, in white chalk, a sentence remained. "The ground remembers what we teach it." When Thomas arrived at MIT that fall, he carried no trophy, no laptop, no suitcase full of medals. Only a jar. Inside, a small handful of red soil from Tulia. He set it on his desk, beside his books. And every now and then, when a problem refused to speak, he would touch the jar and listen, not for the answer, but for the wind and the soil and the silence between. Thank you for staying with us until the very end of this story. If Thomas Hale's journey spoke to something in you, we invite you to subscribe. Not for numbers, but so we can keep bringing you quiet lights like this one, for quiet afternoons. Some geniuses are born on stages, but others grow slowly in the dust. Thank you for listening to them with us.